Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
This episode was generated using artificial intelligence. Please verify facts.
Hello, Herman and Corn, and to anyone listening in. Before sending in today's prompt, I wanted to say that if anyone occasionally might find in this podcast history topics that seem to be being repeated, there are a number of explanations, one of which is me losing my mind. It's always very credible. The second is technical malfunctions. It happens constantly. And the third is what I thought I would share, that it's taken like a long time, probably about a year, not of continuous effort, but of tinkering at this podcast idea to get to the pipeline we have today, which is a fairly stable pipeline at this point. And some of the very early attempts at creating this AI-generated podcast were frankly pretty terrible. The TTS quality was bad. They just weren't good. So I've come to quite cherish this podcast project, and I thought that while it was frustrating to sacrifice some previous episodes, the overall quality of the podcast was better served by doing so. So about 100 episodes, the earlier ones were gone, were lost, and I think this is one of the topics we covered. So Herman and Corn, what we discussed previously in a memory of the podcast lost in my word prompt history was this notion that ChatGPT and AI kind of just exploded overnight. And knowing how complex artificial intelligence is and the general history of huge advances in technology, we know that this didn't just happen overnight. We did talk about the specific leap that the transformer architecture represented and how that's been felt not just in conversational AI models, but really across the gamut in tools ranging from speech synthesis through to speech to text. An actual, a dazzling array of fields that at the surface really don't seem to have much in common, but they've all been kind of catalyzed by the same revolution. But when you dig deeper into, you start asking questions like, well, did someone invent AI, or when did AI start? And as usual, it's kind of an unsatisfying answer that depends how you define artificial intelligence, and it depends how you want to put together the lineage of evolution in it. But really, it stretches back all the way to the start of computing, with previous waves of advancement through natural language processing. And that's what I'd love to talk about today, is the kind of murky world of the evolution of AI, when it was very much a subject that was wrapped up in academia, computer science, and the margins of technology in the prototype setting, and a few glamorous successes, but by and large not attracting a huge amount of attention and remaining fairly decidedly in the realm of this is tomorrow's dream to suddenly becoming practical. And I think that's what makes the AI revolution so unique, is that we're used to, when technology matures, it's kind of a linear process. Whereas with AI, it kind of felt like it got good all at once, and now it's everywhere all at once. So that's what I'd love to talk about, Herman and Corn, how the AI revolution has felt so different than other periods of tech advancement, whether that was the arrival of the internet or just the availability of computers. I didn't live through those like I did AI, but it probably does a great disservice to the work of many people who were working on this for a long time before things like ChatGPT became part of everyone's daily vocabulary. So Herman and Corn, I'd love to talk about the early days of AI. What was it like back then? I'm sure Herman Poppleberry was busy with his quantum computer doing early experiments. And before the transformer model came on the scene, what was kind of the state of play that went from it being this kind of fairly obscure field to something that's just dominating headlines inside technology, but far beyond it too.
You know, Herman, I was looking at some old tech magazines from the late 90s the other day, and it is wild how we used to talk about the future. Everything was about the information superhighway and pocket organizers. But there was this one tiny column in the back of a 2001 issue that mentioned something called neural networks as a fringe academic curiosity. It really puts things in perspective when you look at where we are today in early 2026.
Herman Poppleberry here. And Corn, you are hitting on exactly what our housemate Daniel was asking about in his prompt this week. He was reflecting on how it feels like AI just fell out of the sky a few years ago. One day we are using Clippy to write a letter, and the next we have these massive models that can write code, compose symphonies, and simulate entire worlds. But as Daniel pointed out, and as you just hinted at with those old magazines, this was anything but an overnight success. It was a slow, sometimes painful 70-year grind that only recently hit an inflection point.
It is that classic quote, right? Every overnight success is 10 years in the making. But with AI, it is more like 70 years. It is fascinating because most people's memory of AI starts with ChatGPT in late 2022. Maybe they remember AlphaGo beating Lisa Dole in 2016. But before that, AI was almost a dirty word in some circles. It was the thing that promised the world and never delivered.
Oh, absolutely. If you were a researcher in the 1980s or 90s, you often had to hide the fact that you were working on artificial intelligence just to get funding. They called them the AI winters. There were two big ones. The first happened in the mid-70s after the initial hype of the 1950s and 60s died down. People thought we would have human-level intelligence in a decade. When it did not happen, the government and private investors just pulled the plug.
I think that is a really important point to start with. Why did they think it was going to be so easy back then? I mean, we are talking about the Dartmouth Workshop in 1956, which is generally seen as the birth of the field. What was their approach, and why did it hit such a massive wall?
Well, the early pioneers, like John McCarthy and Marvin Minsky, were focused on what we now call symbolic AI, or good old-fashioned AI. The idea was that intelligence is basically just logic. If you could write enough if-then rules, you could simulate a human mind. It was very top-down. If you want a computer to know what a chair is, you write 1,000 rules describing the legs, the seat, the back, and the function.
Right? But the problem is, the real world is messy. There are three-legged chairs, beanbag chairs, and chairs that look like art pieces. You cannot possibly write enough rules to cover every edge case. We talked about this a bit back in episode 96, when we were discussing the evolution of barcodes and how machines struggle with visual patterns. It is that same fundamental issue of trying to define the world through rigid logic.
Exactly. That is called the combinatorial explosion. As the world gets more complex, the number of rules you need grows exponentially until the computer just chokes. That is why the first AI winter happened. The symbolic approach was great for playing chess or solving math theorems, but it could not handle a simple conversation or recognize a face.
So, if the symbolic approach failed, what was happening in the background? Because the neural networks we use today were actually being discussed even back then, right?
They were. It is honestly a bit tragic. Frank Rosenblatt came up with the perceptron in 1958. It was a very basic version of a single neuron in a neural network. He was so confident that he told the New York Times that the Navy would soon have a machine that could walk, talk, and see. But then, Minsky and Papert wrote a book in 1969 that mathematically proved a single-layer perceptron could not even solve a simple XOR logic gate problem. That book basically killed neural network research for over a decade.
Wow, so one book essentially froze an entire branch of science? That is incredible. But then we get to the 80s, and things start to thaw out a bit. I remember reading about expert systems. Was that just symbolic AI making a comeback?
Pretty much. Expert systems were the big thing in the 80s. Companies spent millions on these massive rule-based systems to help with things like medical diagnosis or oil exploration, and they worked up to a point, but they were brittle. If you gave them a piece of information that was slightly outside their rule set, they would give you a completely nonsensical answer. This led to the second AI winter in the late 80s, triggered by the collapse of the specialized Lisp machine market and the failure of massive projects like Japan's fifth-generation computer systems.
It is interesting how the history of AI is basically a series of hype cycles followed by crashes. It makes me wonder about our current moment in early 26. Are we in another hype cycle, or is this time actually different, because the underlying technology shifted?
That is the big question, isn't it? But to understand why today feels different, we have to look at what happened during that second winter. While the world was ignoring AI, a small group of researchers, often called the Canadian Mafia, kept working on neural networks. People like Geoffrey Hinton, Yoshua Bengio, and Yann LeCun. They were supported by the Canadian Institute for Advanced Research, or CIFAR, which was one of the few places willing to fund what everyone else thought was a dead end.
The Canadian Mafia. I love that. It sounds like a group of polite but very determined scientists. And it clearly paid off. I mean, Geoffrey Hinton shared the Nobel Prize in Physics in 2024 with John Hopfield for their work on neural networks and machine learning. So, they were working on backpropagation and multi-layer networks while everyone else was focused on the internet and dot-coms. What was the missing ingredient back then?
It was the three pillars: algorithms, data, and compute. They had some of the algorithms, like backpropagation, which allows a network to learn from its mistakes by adjusting the weights of its connections. But they did not have the data, and they definitely did not have the compute. In the 90s, if you wanted to train a network to recognize a cat, you had to manually feed it thousands of photos, and a top-of-the-line computer would take weeks to process them.
And then the internet happened. Suddenly, we have billions of photos, articles, and videos being uploaded every day. We inadvertently created the world's largest training set. But even with all that data, you still need the horsepower to crunch it.
Right. And that horsepower came from an unlikely place: video games. This is one of my favorite parts of the story. Researchers realized that graphics processing units, or GPS, which were designed to render pretty pictures in games like Quake and Doom, were actually perfect for the type of math needed for neural networks. Specifically, matrix multiplication. A CPU is like a very smart professor who can do one hard problem at a time. A GPU is like 1,000 high schoolers who can each do one simple multiplication problem simultaneously. For AI, you need the 1,000 high schoolers.
That is a great analogy. It is funny to think that the reason we have modern AI is partially because teenagers wanted more realistic explosions in their games. So, when does the explosion Daniel mentioned actually start? Is there a specific moment where the academic world realized the game had changed?
There is a very specific moment. It is 2012. The ImageNet competition. For years, researchers had been trying to get computers to identify objects in photos, and the progress was slow, maybe improving by 1% or 2% each year. Then, a team from the University of Toronto, led by Hinton, entered a neural network called AlexNet. They absolutely obliterated the competition. Their error rate was 15% lower than the next best team. That was the moment the industry realized that deep learning, which is just neural networks with many layers, was the future.
I remember that being a big deal in the tech news. But even then, it felt very specialized. It was about computer vision. It was not something the average person was interacting with daily, unless they were using Google Translate or something. How do we get from recognizing a picture of a cat to a model that can explain quantum physics to a 5-year-old?
That is where we get into the realm of natural language processing, or NLP. For a long time, NLP was stuck in the same rut as computer vision. We were using things called recurrent neural networks and LSTMs, or long short-term memory networks. They were good, but they had a problem with memory. If you gave them a long paragraph, they would forget the beginning by the time they got to the end. They processed words one by one in order.
Which is how humans read, but I imagine it is very inefficient for a machine that wants to understand the context of an entire document at once.
Exactly. And then came 2017. A group of researchers at Google published a paper with what might be the best title in the history of computer science: Attention is All You Need. They introduced the transformer architecture. Instead of reading words in order, the transformer uses a mechanism called self-attention to look at every word in a sentence simultaneously. It figures out which words are most relevant to each other, regardless of how far apart they are.
So, if I say the bank was closed because the river overflowed, the transformer knows that bank refers to the edge of the river, not a financial institution, because it sees the word river at the same time.
Precisely. It can parallelize the processing, which means we could suddenly train models on much, much larger data sets. We went from training on books to training on the entire public internet. And because it was so efficient, we could make the models bigger, more parameters, more layers, more intelligence.
This is where the scale comes in. We talked about this back in episode 200, when we looked at the modern AI tech stack. It seems like once we had the transformer, the path to GPT-3 and GPT-4 was basically just a matter of scaling up the compute and the data. But it still feels like there was a jump in capability that surprised everyone, even the researchers.
It did. These are called emergent behaviors. When you scale these models to a certain point, they suddenly start being able to do things they were not specifically trained for. They were not trained to write Python code, they were trained to predict the next word in the sequence. But it turns out that to predict the next word in a Python script, you have to actually understand the logic of Python.
That is the part that blows my mind. It is like if you memorized every word in the library, and suddenly you realized you could speak 5 languages and solve calculus problems just because you've seen the patterns so many times. But let's bring this back to Daniel's question about the transition to the mainstream. Why did it take from 2017 to 2022 for the general public to feel the impact?
It was the interface. We had these models, but they were hard to use. You needed to be a developer, you needed to know how to prompt them via an API, and they were still a bit wild and unpredictable. OpenAI's genius with ChatGPT was not just the model, which was a fine-tuned version of GPT 3.5, it was the chat interface. They made it feel like you were talking to a person. They used something called reinforcement learning from human feedback, or RLHF, to align the model's responses with what humans actually find helpful and safe.
It is like they took this raw, powerful engine and finally put a steering wheel and a dashboard on it. And suddenly, my mom is using it to plan a vacation, and students are using it to help with their homework. It moved from a lab to the kitchen table.
And that is the transition Daniel was talking about. But even since then, things have moved again. We have transitioned from the era of fast chat to the era of reasoning. In late 24 and throughout 25, we saw emerging models like OpenAI's o1 and o3, and Google's Gemini 2.0, which actually pause and think before they answer. They use something called inference scaling to work through complex problems step by step. It is what researchers call System 2 thinking.
So we have gone from a statistical engine that guesses the next word to a system that actually plans its answer. That is a huge shift. Does the fact that it feels like it exploded overnight make it more dangerous because we have not had time to adapt our culture and laws? That is a deep one. I think there is a real risk of future shock. When technology moves faster than our ability to understand its implications, we make mistakes. We saw this with social media. We did not realize how it would affect mental health or democracy until it was already woven into the fabric of society. With AI, the stakes are even higher because it touches everything: work, education, truth itself. We are still catching up to the fact that a video can be perfectly faked, or that an essay might not have a human author.
I agree. And it is not just the social impact, it is the technical one. Because it happens so fast, we are still figuring out how these models actually work under the hood. We know the math, we know the architecture, but we do not always know why a model makes a specific decision. It is the black box problem. As we discussed in episode 251 regarding privacy and backdoors, if we do not understand the internal logic, how can we truly trust it with critical infrastructure?
It is a bit like we've tamed a wild animal, but we're not quite sure if it's actually tame or just waiting for the right moment to do something unexpected. But let's pivot to the practical side of this. For someone listening who is not a computer scientist, what is the takeaway from this long history? Why does it matter that it started in 1956?
I think it matters because it gives us a sense of perspective. It reminds us that we are not at the end of the story, we are probably just at the end of the first chapter of the practical era. If it took 70 years to get here, imagine where we will be in another 20. It also helps to bust the myth that AI is magic. It is not magic. It is an incredible feat of engineering and math that relies on very human things, our data, our feedback, and our curiosity.
Right. It is a mirror of us, in a way. It is trained on our collective knowledge. One of my takeaways is that we should be looking for the next transformer. There is a tendency to think that large language models are the final form of AI, but history shows us that every dominant paradigm eventually hits a wall and gets replaced by something better. Right now, in early 26, everyone is talking about physical AI, putting these brains into robotic bodies that can actually do laundry or cook a meal.
I love that you brought that up. Physical AI and autonomous agents are the huge areas of research right now. It is the idea that we need to move beyond the screen. If we can give a neural network the ability to interact with the physical world and follow hard logic rules when it needs to, we might finally solve the remaining hallucination problems.
Exactly. It would be like giving the creative, intuitive part of the brain a more rigorous, logical partner to check its work. Which, funny enough, sounds a lot like our dynamic here, Herman. You dive deep into the research and the data, and I try to poke at the implications and the logic of it all.
Guilty as charged. And that is why I find this field so exciting. It is not just about the code, it is about how we think and how we learn. Another practical takeaway for listeners is to realize that the AI you see in the headlines is just the tip of the iceberg. There is so much happening in specialized fields like protein folding for medicine or climate modeling that does not get the same buzz as a chatbot, but might actually have a bigger impact on our lives in the long run.
That is a great point. We focus on the things we can talk to, but the things that are working silently in the background are often more transformative. It is like the difference between a flashy new car and the invention of the internal combustion engine. One is what you see, the other is what actually changes the world.
So, looking at where we are now, in early 26, what do you think is the biggest misconception people still have about AI, given this long history?
I think the biggest misconception is that AI is thinking the way we do. Because it is so good at language, we naturally anthropomorphize it. We think it has intentions or feelings, but when you look at the history, from the perceptron to the transformer, you see it is really about pattern recognition at a scale we can barely comprehend. It is a statistical engine, not a sentient being. And confusing the two can lead to some really bad decisions, whether it is in how we regulate it or how much we trust it.
That is spot on. It is a tool, an incredibly sophisticated one, but a tool nonetheless. It is like a superpowered version of those old expert systems, but instead of us writing the rules, the machine found the rules in our data. But it does not know what it is saying. It just knows that in this context, these words are the most likely to follow those words.
It makes me think about Daniel's point about it becoming an everyday tool. We are moving from the wow phase to the utility phase. It is becoming like electricity or the internet. You do not think about the history of the power grid when you flip a light switch. You just expect the light to come on. We are reaching that point with AI where it is just there. It is in our emails, our maps, our medical records.
And that is when it gets really interesting, because that is when the second order effects start to kick in. When everyone has access to a world-class tutor or a legal assistant in their pocket, how does that change the economy? How does it change the value of a college degree? These are the questions we are going to be tackling for the next decade.
It is a bit like what we discussed in episode 151 about internet speeds. Once the infrastructure is there, the way we use it changes completely. We move from just having the internet to living on it. We are starting to live with AI.
We really are. And I think we should take a moment to appreciate the sheer human effort that went into this. All those researchers who worked through the AI winters when no one cared, who were told their ideas were dead ends. People like Hinton, who spent 30 years being the odd man out in computer science. Their persistence is the reason we are having this conversation today.
It is a good reminder to stay curious and not to dismiss things just because they are currently out of fashion. The weird idea of today could be the mainstream tool of tomorrow. That is basically the mission statement of this podcast, right?
Exactly. Exploring those weird prompts and seeing where they lead. And speaking of curiosity, if you have been enjoying our deep dives into these topics, we would really appreciate it if you could leave us a review on your podcast app or over on Spotify. It genuinely helps other curious minds find the show.
It really does. And if you want to get in touch or see the show notes for this episode, you can always find us at myweirdprompts.com. We have the full archive there, including all those early episodes Daniel was mentioning earlier.
Yeah, we have come a long way since those first 100 episodes. It has been quite a journey, much like the history of AI itself.
Well, I think we have covered a lot of ground today. From the Dartmouth Workshop to the Transformer, and why Daniel's feeling of an overnight explosion is both right and wrong. It is a fascinating story of human persistence and the power of scaling simple ideas.
It really is. Thanks for the great discussion, Corn, and thanks to Daniel for the prompt. It is always fun to look back at the roots of the tech that is shaping our world.
Definitely. All right, everyone. Thanks for listening to my weird prompts. We will be back next week with another deep dive into whatever is on Daniel's mind.
Or yours, if you send us a message. Until next time.
See ya.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox Turbo.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.